power button.
Is it on? Okay. So, do you want to do like that? As status. Talk about where we are.
Yeah, we can do that.
Summarize that. All right. Okay, welcome. It's that time. It's Singapore and Tuesday, so I guess it must be time for token mining. Let's start with our usual note. We're pretty far into this, but for newcomers, it's worth to note the IPR rules of the IETF and how to relate to them. And from now on, I'm going to assume that you understand this stuff. We have a fairly light agenda today. We're going to get updates on 2 of the documents that are still being sort of processed by the working group. And but before that, John's going to sort of give an update on where we are with our core documents, are currently in ISG review. I did a screenshot of the data tracker to help John.
Of course, I can't see it from here, but I could get it. This one has a switch.
All right.
Okay. So the 3 specs, HTTPS, token binding negotiation, and token binding protocol. So we've been through with the with our responsible AD, both of those documents, and he's pulled the plug on the 2-week review period. We met with him this morning. He had a couple of issues or questions around the HTTP, around the redirect federation stuff. So we agreed to add some explanatory text saying essentially this is intended to be used with existing federation protocols that actually have audiences and other things. That if you were to invent a completely new federation protocol and just try to use token binding, your mileage may vary. It's probably not a good thing to invent a new federation protocol without appropriate security reviews. I mean, God knows what somebody might attempt to do just using token binding in a cookie. So with a bit of explanation, so he's going to also pull the, submit that suggested today based on our agreement to update some security and implementation concerns.
Mike Jones, clarification question. So he is asking for clarifications of the exposition, no normative changes.
No
correct?
normative changes.
Right.
Thank you.
It's basically to clarify the underlying assumptions that go into the term federation, right?
Fair enough.
Right.
So he was concerned that a bad party could do an HTTP redirect, ask for a token bound something, and then be able to do something with that. And in our discussion, we attempted to explain that there is nothing more that you could do than what you could already do with a bearer token, at which point you're completely screwed. You would have to, even if you got every single security thing wrong, you would have to get a bunch of security things wrong to be able to exploit it with token binding. So it, I think we're in a good shape. He seemed to accept our explanation. So that's essentially it. Hopefully we can force this through the IESG and get it done by the end of the year.
Right. So for the rest of our agenda, unless anybody has questions or comments about the status of core documents, but it does look like we're sort of seeing the end of the tunnel there. Yeah, it's good work. All right, I think we leave the floor up to Nick to come talk about. Let's see if I can bring that draft up.
So I'm actually not talking about zero RTT as is listed on this agenda. I'm talking about TLS 1. Token binding negotiation for TLS 1.3, as in like 1 RTT. So yeah, this is a short, like 4-page internet draft to describe how to update TB nego for TLS 1.3. Next slide, please. There are really only 2 changes that this draft covers. The first change is to the token binding TLS extension. So in the client hello in both TLS 1.2 and 1.3, we send the token binding TLS extension in the client hello. In 1.2, the server, if it's negotiating token binding, puts the extension in the server hello. This draft updates that to say that in TLS 1.3, that extension goes in encrypted extensions instead. TLS 1.3 also requires that all new extensions describe their interaction with zero RTT. This draft says that you cannot have both token binding and early data in encrypted extensions, i.e. you cannot have both token binding and zero RTT in the same thing. This leaves it up for the zero RTT draft, which I had previously started work on, to update this draft to say how you can do that. And just as a note, it is allowed to have both token binding and early data in the client hello. This means that a client which can do zero RTT to a particular server but has not done token binding is saying that I also support token binding and am willing to do token binding instead of zero RTT on the connection if the server supports that. Next slide. So yeah, section 4 is just an update of the token binding signature definition. In TB Proto, it describes that in terms of the RFC 5705 EKM value. TLS 1.3 provides a new definition of an exporter, but we keep all of the same parameters. There might need to be some wordsmithing here, but essentially I tried to make this be a non-normative section to say, by the way, here's what this looks like, but it's just the same as the previous draft. So yeah, that's basically all that is in this draft. Yeah.
Right. So I guess this begs the question of next steps for this, right? Where do we go? Where do we take this, right?
Yeah, so what we can do with this is my suggestion would be that the working group adopt this as a work item, and this would be a separate draft from the zero RTT draft. Another option could be that we just merge both of them into one draft for doing, it's one draft for updating token binding for TLS 1.3.
Right, so that's a good question for the working group. What do you guys want to do with this? All in one or separate drafts or what? Yes, now's the time to run for the mic.
Mike Jones, Microsoft. To the question of whether to merge them, is it ever meaningful to implement one without the other?
Yes, I think it's very meaningful to implement this draft without the zero RTT draft. An implementer could decide that they don't like the security properties of zero RTT token binding and choose just to implement this one.
Thank you.
Andrei Popov, Microsoft. Just, my take on this is that token binding with one RTT makes a lot of sense, and token binding with one RTT TLS 1.3 has about the same security properties as it does with previous versions of TLS, whereas token binding with zero RTT has weaker security properties, and to me it's actually questionable whether that's worth implementing. So I would like to see those drafts separate and go their separate ways in the working group.
Right, and this is sort of the situation now anyway, right? So I guess this, if nobody else has an strong opinion about this, I think the question on the table is whether to adopt this work as a working group item and move forward with it. right? Anybody, if there are nobody else who wants to express opinions about that, we can do a quick consensus call in the group. So for our first couple of hums, the first one is support adopting this as a working group item. The second would be oppose, and the third is, need more information / don't care. All right. So hum if you like the idea of adopting this as a working group document. Right. Oppose. Don't know, don't care, need more information. No. Okay, so that's fairly clear consensus on adopting this as working group item. So I go ahead and post a revision as a 00. We can communicate separately on a name, right? But yeah, we'll confirm it on the list. But this was fairly strong consensus, so
Okay, thank you.
Yeah, we can talk about the name while we wait for the list to sort of. All right. And that means we're time for Brian. Is this the right slide, by the way?
Looks good.
Okay.
All right. So I'm going to talk about HTTPS token binding in conjunction with TLS terminating reverse proxies. Title slide, which has document identifier and everything on it. So I'm going to repeat a lot of what I've said in previous meetings, but kind of give an overview of the problem statement. Is that HTTPS applications are very commonly deployed behind some kind of TLS terminating reverse proxy. And it's that sits between the client and it. It's a very common application deployment pattern, not the only one, but it comes up quite a bit. And this is true sort of across all spectrums of deployment. There's products that do this, like in F5, there's open source solutions that do this, your Nginx or your Apache. And increasingly there's services that do this sort of thing, like Cloudflare or application load balancer from Amazon, or a variety of them. So it's sort of applicable to both the old deployment patterns and the new. And the issue here is that in order for applications that sit behind one of these terminating reverse proxies to actually take full advantage of token binding, some kind of information needs to be passed from the component that's terminating TLS back to the application, at least in the general case. I know there's an example of the Nginx plugin that sort of automatically binds cookies for you and sort of makes that transparent to the application. But in order to do more general things, all you might want to do with token binding, including some of the federation use cases, you really need to expose more information to the backend application and let it somehow do the binding and the verification. In the absence of some kind of standardized documented way to do this, different deployments are going to do it differently, and that's obviously really bad for interoperability. Ideally, we'd have something here that is documented and standardized enough that it can be a turnkey solution, so that if I'm running my application behind Cloudflare, I can flick a configuration switch in Cloudflare and code to the standard of flip a switch in my application, and things just work. So that's the goal. That's the problem statement. Next slide, please. Maybe. My browser. Oh, there it is. There we are. Just a little bit of history on all this. So I first brought this up in Seoul, and we got a rough consensus to work on the problem from the working group. There were two general approaches discussed at that time. They're still valid today. You can kind of do it one of two ways. One is to expose the token binding IDs to the backend application somehow, and the other is to expose the EKM and a few other things to the backend. Coming out of that meeting, I got the sense that people were liking the EKM version of the idea, so I wrote a draft, Campbell tokebind TLS term 00, and that exposed the EKM to the backend and a few other items, but mostly the EKM to the backend as a header. Thankfully, along the lines there somewhere, Jeff coined the term TTRP, which has saved me a lot of typing in the meantime. Thank you. And but there was some pushback on that approach from a number of people, largely from people actually implementing some work in Apache and Nginx. about sort of the complexity of doing it, more so for the back-end applications, negotiating the types and sort of simplifying, making it simple to adopt it from the back-end application approach. Wanted to talk about that draft in Chicago, and I did a little bit, but we were a little rushed. I was at the end, and the meeting was cut short in the main session due to time, working on more important things like the core drafts. So what I did was announced an open side meeting that week in the I don't know what we call it, the ad hoc room, which another number of people came to. I announced it on the list. A number of people came to it, and talking through some of the issues there was a clear preference within that room that favored the approach of passing the validated token binding ID to the backend application. So in between that and Prague, I wrote a new draft, and it does exactly that. It exposes the token binding IDs to the backend. There was an editorial update to that, and then into Prague. Next slide. At Prague, or shortly after, we got consensus to adopt that version of the document as a working group draft. And the only real concrete feedback at that time that I was able to act on was to add the sec prefix to the headers that I was working with. I'm not sure it really adds much, but there was a desire to do so. It at least limits those being able to be set from JavaScript within the browser. So we did that, and that's in draft 01. And next slide. So just kind of getting into the nitty-gritty details of how it works. The draft defines HTTP headers, and this enables the TTRP and the backend application to function as a single logical unit implementing token binding. And it works by the TTRP negotiating token binding with the client and validating the token binding message from the sec token binding ID header, and then removing that header from the dispatch request to the backend. What it does then is adds a sec provided token binding ID header with the base64 URL encoded provided token binding ID, adds that to the dispatch request, and then if applicable, if there's a referred token binding, it does the same thing with the referred token binding with a different name, predictably named with sec referred token binding ID. This requires some level of trust between the TTRP and the backend, which is very, very common for these kind of deployments, more or less required in all of them. And it requires the TTRP to sanitize the headers. So if the client tries to inject the sec provided token binding ID header, the TTRP has to strip that and remove it so that there can't be sort of impersonation isn't the right word, but basically impersonating the token binding ID key from the client. The TTRP needs to prevent that from happening by sanitizing any of the headers that come through. And just a side note, the original token binding ID message, or sorry, the original full token binding message is not provided to the backend because it's dropped from the original request. Next slide. And it's pretty simple pattern, but sometimes pictures are a little bit helpful, so I tried to draw it up here. From the client and the reverse proxies perspective, we're doing old-fashioned token binding over HTTPS. And that includes the TTRP negotiating, obviously. It validates the token binding message, does header sanitization, and then if all is good with that, it removes the sec token binding header that would be here, adds in the sec provided token binding ID header, and that again is just the base64 URL encoded token binding ID of the of what came in the original request. And this is very much in line with what's suggested in the token binding draft, which is the token binding protocol draft, which is to make available to the application the raw token binding ID for doing the binding. And it passes that to the backend. And then so if the backend application is issuing a cookie, it can bind to that. If it's verifying a cookie, it can verify against it. But the actual work of validating the message is done in the reverse proxy. And next slide, please. So the elephant in the room, or at least what I thought would be in the elephant in the room, but I don't see Eric here. In Prague, there was some concern expressed about this approach, largely about header injection, using sanitization as the means to prevent that. And the concern that was raised was that it doesn't fail safe. So if it's not properly implemented, or it's partially deployed or not properly deployed, it doesn't fail safe in that there's no way for the backend application to detect that a client's injected the header. It has to sort of blindly rely on the TTRP to strip those. But in my humble opinion, client header injection through reverse proxies is not at all a unique problem to this particular application of token binding or the functionality of this draft. And I think it would be wildly inappropriate for this draft to try to define some one-off additional mechanism for preventing this. And the reality is that stripping or sanitizing headers right now is the de facto means of dealing with this sort of thing in practice today. And it's sufficient when properly implemented, and it's normatively required by the text in the draft.
Is it too early to ask a question?
Let me get through this slide, maybe. And I further wanted to say that the unsafe failure mode, which it is if the failure is there, but it's sort of not exactly fully catastrophic. If the proxy isn't correctly sanitizing headers, if it's implemented improperly, or if it's somehow sort of half deployed, half not deployed, the failure mode isn't exactly catastrophic. You lose you potentially lose the protections afforded by token binding, which isn't great, but it's basically the current state of just about everything on the web today. So the failure mode is just sort of falling back to where we are today. So in my view, I guess the summary here is, in my view, the current functionality of the draft requiring the TTRP to sanitize the headers as appropriate is sufficient and appropriate for the security mechanism of the draft. And yeah, please.
Yeah, just a question.
Yeah.
One way
hang
of
on,
doing...
just state your name. Everybody state their name at the mic.
Stefan Santesson. So one way of making this fail-safe, I think, would be, for example, offer a mechanism with a shared secret to HMAC the data from the server to the backend application from the proxy. Have you considered that as an optional mechanism?
So there's a lot of ways, all variants of maybe HMACing the data, maybe placing some sort of shared secret just in a header indicating that the processing has occurred, listing out the various headers that have been processed by the reverse proxy. There's a wide variety of ways to try to address the problem. What I'm saying is that it's a broader problem than just this particular draft. And I don't think it makes sense or is appropriate for this draft to define a single sort of one-off solution for this. It would be nice if a broader solution existed that maybe we could point to. But in the absence of that, I don't want to try to solve the bigger problem here. I don't want to take a one-off approach to solving it for just this particular set of headers, and would prefer to rely on what's currently in the draft.
So you probably spend way more time than me on the problem, but it feels still to me that you're making the wrong conclusion, because you are defining a header ID which carries some data, and you have the opportunity to specify the syntax and the conventions for that data to be passed. So it's your opportunity also to specify how I could have security data like HMAC going with it if I could have a pre-shared key. If it's important for me to make sure fail safely that this data actually originates from the reverse proxy.
And establishing shared secrets between the systems is one thing that I'm looking to avoid. Well, it could be optional. I guess it could be optional. I would prefer simplicity in the draft and in deployment, and hopefully adoption versus on top of security that I believe is sufficient today, versus adding optionality or additional complexity or additional sort of key management requirements between systems.
Mike Jones, Microsoft. Another thing we discussed at the previous IETF
It's on the next slide.
is this. I'll wait till the next slide then.
I think, if you're going to say what.
I took that as a cue.
Yes, do your slide, then I'll speak.
Well, just going back to so I sense there are a few people that would like something more. I think, pretty clearly against adding additional functionality to try to.
So one thing, we did actually have this discussion. I can't remember which mailing list this was. It on SAG? It was sort of this.
It was combined on a couple of lists.
Yeah, and there was actually some people expressed appetite for doing something general, right?
Yes.
But nobody suggested that token binding was sufficiently different to warrant a special mechanism for this, right? So in fact, they actually don't bear you out, Stefan. I mean, at least that was the consensus in the discussion that happened when this was brought up by Eric Ruscola after Prague, right? You know, so we've basically already covered this, and you know, I'd be totally excited about and support like a general mechanism. Just that nobody stood up to do that yet, right? Somebody should, right?
I've offered to help if somebody's interested
exactly.
in doing it, but I don't want it to hold this up. And
And
there's
nobody,
been a lot of different
right.
ideas, but no one's really.
Right, and nobody suggested that this be held up. I mean, even Ecker hasn't suggested that, right?
Okay, I was feeling like he sort of did, so I was trying to address it.
But I think he sort of backed down from that actually.
Okay.
So I'd be surprised if we land there.
All right, then we can move from there. Thanks. Next slide, then. The elephant's supposed to be cute, though. So the other issue that was raised in Prague was support for other token binding types. In the current draft 01, there's only explicit support provided for the provided and referred token binding IDs via these two headers that we talked about before. From the 99 minutes, I went back and looked at that someone has use cases that require more than 2 token bindings. And a use case description of that was requested and has not been seen. Because
I gave it verbally at IETF 99. I can
more,
do it again here.
Well, a more detailed description was requested because I guess I'm looking to understand the case and whether it really warrants standardization for something like this. And beyond that, looking for a little bit of input and consensus from the working group, whether it makes sense here. Because at least the way that I understood your use case was that you had Microsoft developed clients talking to Microsoft developed backends, doing something with a proprietary Microsoft token binding type, and that is valid and reasonable use case, but I don't think makes sense in the context of this kind of standardization.
This is Mike Jones at Microsoft. I'm going to turn the question on its head, if I may. The token binding protocol document and the token binding HTTPS document can communicate token binding IDs and security information associated with them for 256 token binding IDs. If token binding IDs other than 0 and 1 are used in this document, that information is thrown away. That's not good protocol design.
It's a presumption of extensibility and application here that you're right. If there's another token binding ID that comes up in the web context, it would
You're
be
going to
dropped.
toss it.
Yeah, yes.
And that's not good protocol design.
It's great protocol design if it keeps it simple and that case never arises. And so the request for
but that's an assumption that isn't borne out in the token binding protocol document or the token binding HTTPS document.
Well,
and I can write this on the list, but the short description is if you have something with multiple audiences and those audiences are well known, if you're following good token hygiene, you're going to have different token bindings for one audience than the other. And, you know, you can use the proprietary word all you want, but these features would be available to Microsoft customers as well as Microsoft.
I guess I would be interested in actually seeing what it is, having written down what it is, and getting some some input and consensus as to whether this is in fact an extension point that we want to allow for in the standard.
It's not an extension point. It's not throwing information away.
It's not.
You should have to justify tossing information that's present in the underlying protocol.
It's an extension point in the underlying protocol because there's 2 defined and there's 254 extension points available, and so it's a.
But you shouldn't presume they won't be used.
I'm presuming they will not be used in this
Right.
context.
I think that's bad protocol design.
And I think it's simplifying the protocol where appropriate.
It's cutting off use cases anyway.
So I'm asking for an actual description of the use case.
So, Nick Harper, I was going to point out that the token mining protocol also defines extensions,
Yep.
Which is a separate space than these 256 types of token bindings. And right now, TTRP doesn't describe anything to do with the extension. So, to Mike Joyden's point, that's throwing away information. But I think that's acceptable in this case. I think that TTRP is designing a protocol for the majority of use cases, not all of the use cases of token binding. And I think that's acceptable to have a protocol that is covering the majority of use cases. If there, and in the future there might be extensions that are defined to extend it. It's not going to support it, and I think that's okay today. We don't know all of the ways that's going to be used. Let's make something that is generic enough for what's going to be used, but we don't need to worry about every single possible edge case in it.
So
right
can
now.
I just ask a question to Mike? Would you be more happy if there was a path to extensibility that match in TTRP that matched what the extensibility in the core protocols?
Yeah, I want it to be defined how this additional information that may be present in the underlying protocol is passed through. I recognize that most of the initial use cases won't have that header or headers, whatever they are, but I do think they should be defined.
So if you stay at the mic, I just want to clarify. So there's a difference between sort of making a one-to-one representation and making a representation for the majority case, but with extensibility that optionally covers all the other cases if and when you need them, right? So,
Sure.
Right?
I agree with that.
Yeah, and I want to I want to ask a question about the second case, right? Would you be more happy if, yes, everything isn't carried through today, but here's how you would if you wanted to?
That's exactly what I'm asking.
I'm just trying to find consensus, right?
Well, I think you're asking for a defined mechanism here.
Yes.
And Leif, I believe, was saying, would it be sufficient to have some wording that said here would be the extension thereof if you wanted to pass that in the future, which is
but
not.
If the goal of your draft, as stated in your introduction, is enabling interop among such terminating servers, then you have to actually define the mechanism.
Yes, for things that are defined, and I keep coming back to that. There's no other current definition of other token binding types.
So
Yes, there are. It's 2 through 255. Just
So-
because they don't have a name doesn't mean that they don't have identifiers.
So I have a question. Since we don't know what these other token binding types are there specific processing rules that the reverse proxy would need to know to actually be able to extract the appropriate information from the token binding types, or is every token binding ID exactly the same with a different number?
Yes.
That's what we have so far.
Vinodan from Google. I'm guessing what Mike is saying is if the names of the headers were sec token binding ID 0, sec token binding ID 1, blah, 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 you covered for all the cases. But then in the interest of usability of the spec,
Sure.
it's much clearer if you're saying referred token binding versus provided token binding. So Mike, is the question that come up with a way of allowing the undefined ones to be passed through as well?
I think so. That was what was requested at the
Right,
last
and
meeting.
I'm kind of pretty agnostic as to the syntax.
I mean,
I would be okay with an other token binding IDs syntax where there's pairs of numbers and IDs, all encoded in some string. I would be okay with sec token binding ID 2, sec token binding ID 255 being defined. Use whatever syntax you think you want. I recognize that most initial implementations won't have it, but I think we shouldn't be throwing away information which is present in the underlying protocol, especially when we know that there are multi-audience use cases which are real. Anyway, that's my request.
Do you think that you guys could sit down and sort of come up with I mean, it's always easier for the working group to have opinions about stuff like this if there is concrete text, right? If you guys could come up with a few lines, right, defining this, right? It shouldn't be that difficult, right?
I don't think technically it's particularly difficult to solve. It's an additional header with or multiple headers, although that makes the sanitization process significantly more difficult because you have to look for all 256 headers, which is a bit awkward.
I'm not saying we have consensus. I'm trying to figure out a way for us to determine whether we have consensus. And it's always easier to have some.
I guess my request
I suspect as an engineer, defining one other token binding IDs header, which may or may not be present, is fine.
My request here is to actually understand, and maybe it's just my lack of understanding, the use case behind this. Not just that the underlying protocol has 256, but what's the use case that you've stated you currently have for it?
It's because we have what would be OAuth resources, which themselves then become authorization servers to other things that are logically OAuth resource servers. In particular, there's this thing called the Microsoft Graph, where a client is the resource, but then it gets a token which it wants to play to the graph, and it's on a different TLS session. And if you don't have it token bound, all the reasons we're doing token binding go away.
So
it's not very hard.
So it may be useful to actually document that, because given that the token binding message needs to be signed by somebody that has the private key over the EKM, there may be actual things that prohibit having it make sense to send those token bindings. So it would be useful to actually sketch out who's signing what and what does it mean, so that we have as engineers, if it's concrete in our mind what's going on, then maybe it'll be easier to make progress.
Right, and I may be able to do this with Tony. I may have to go back to
I tried to
our
extract the
enterprise
information from Tony, but that
I may have to go back to our enterprise architects next week to actually get it, but I can work on a syntax proposal with Brian this week.
All right, then.
Right. So, but did I hear an agreement that you guys actually try to come up with a proposal? I mean, at least Mike, come up with a, right. You will offer concrete proposal, right? On the list, working group says, have its say about it, and we'll take it from there.
Yeah, I would ask that the problem statement also be described concretely in there so that we can see whether the proposed solution actually addresses the problem. Because if we're passing through multiple components, then I'm not sure it actually works just to expose the other IDs to the back end. So, yeah, we'll work on it.
Right.
All right. And the last one is, that's okay. It's just yeah. Until next time, which is in London. That's London. Any other comments or questions?
So can I ask who has read the latest version? Hands up. All right, a few people. All right. And I mean, other than the discussion we just had, do you have like open issues that you need to address?
The sanitization piece, but it sounds less open than I thought it was.
All right.
So no, that's the only open issue.
I mean, the sanitization could crop up in ISG review or something. We'll
address it then.
We'll address it then. But I guess the other question I was going to ask about, what do you know about the implementation status? Are you talking to implementers who are sort of signing on to this, saying, yes, this is how we want to implement it?
There's not a lot out there, but I've been working with there's one in Nginx. Can you speak to it? I know your original approach was similar but somewhat different in passing a hash rather than the full ID.
Piotr Sikora, Google. Yes, it was a little different, but I don't have any issues with updating it to the current draft, and I think it's fine.
Okay.
And also, since I'm already up, the question regarding token binding types, is it fair to block this on unregistered token binding types if the original protocol doesn't define any? Like, presumably, if we want to add new token binding types, we would need to add them to the original protocol anyway, right? And define their meaning.
I think you, or it could be. I mean, it could
but
be.
Then it's not the interoperability between them is not defined, right?
Not at the reverse. It's not defined at the reverse terminating proxy level, but all the reverse terminating proxy has to do to enable interoperation is to faithfully pass the information between the protocol endpoints. Yes, particular federation protocols or authorization protocols, etc., would have to define how these things are used and why. But that's not the job of this document. The job of this document is just to do faithful information transmission from a terminating proxy to its client.
Yes, my point was about the fact that there is no defined interoperability between client and server anyway, regardless of reverse proxy, right? If you are using some internal version, so to speak, of token mining, right?
That's right.
And I'll just say on top of that, there's a Apache module for token binding that already implements this.
Mm-hmm. All right.
Well, and it implements the old way too, but it's done.
All right, so there are some implementations.
There are some, yes.
All right.
Yeah, Vinod Anupam, Google. In fact, our implementation in the TTRP is exactly, well, we're not using sec header there, but roughly the same thing.
Similar.
So we can easily change to using the standard headers.
But again, in your case, it's maybe less important since you own the infrastructure top to bottom.
But we like having standards compliant implementation.
And maybe if you were going to enable, if you had your terminators in front and were exposing this stuff to, App Engine deployments or something like that, then it would make a lot of sense.
Andrei Popov, Microsoft. So without taking sides in this debate, I think it's totally possible that a future specification will define different types of token bindings. I think such a specification could also define new ways of processing those new types of token bindings, at which point the currently proposed design of TTRP seems to have an issue, because it looks like the smart proxy that actually implements token binding needs to know how to process those new things correctly. So I think there is a tension there, and there's also no negotiation per se. Well, I mean, I guess you negotiate the version of token binding with the TTRP at that point. But anyway, so I think that if you have a new type of token binding and it has different processing rules, then the TTRP has to be intimately familiar with that, because it does all the work and only passes the result to the backend in this specification. So I think there is some complexity If we were to go with the other way, where the actual endpoint server does the validation, and the TTRP just passes along the the information, I think it would have been easier to accommodate new token binding IDs in that other design. That's just how it feels to me. Thanks.
It depends on the processing rules, I guess. And there is a certain set of processing rules that are defined currently in terms of what the signature verification is. That could happen in either place. And my understanding of the ask is to presume that new types would follow those rules and those rules only, and then to pass the validated binding onto the back. We'll work on it. And get to a point where we can at least, I guess, put the question in front of the larger group as to whether it's something we want to include. But yeah, those are the only, there is some implementation. I'm hoping there'll be broader implementation interest once things roll, but there's some already. And that's the only open issue that I'm aware of.
So in terms of rough timelines, we've been asked to update our milestones. They are somewhat temporarily challenged at present. So are we talking like at least till London, you think, before we can expect to have see a working group last call here? All things being equal.
You were hoping for working group last call now, weren't you? You have that look on.
No, I wasn't. Knowing that these were outstanding, I wasn't expecting that. I think being realistic, probably around London might be a reasonable expectation to go into, or at least start talking about working group last call.
Right. I mean, we do have one serious open issue here that we're talking about, right? And there doesn't seem to be a lot of other things floating around. But so okay, and just to bring back Nick into the discussion, the same question for 1.3. Where would you? How much time do you expect to have to spend before you're sort of?
For 1RTT 1.3, I think that will be. It's a really short draft, so. I wouldn't be surprised if that's ready for last call in London. For 0RTT, that one might need a little more time, probably just waiting for implementations to see that people have actually implemented it.
Right. So London-ish for 1.3 and later for 0RTT. Was that?
Yep.
All right.
All right. That's it. Thanks.
That's it. And that was.
Okay.
That means open mic.
Well, we have this one. That you're
We have
talking about.
at the station, yeah.
You want to plug this in, or?
All right.
Yeah, but no.
Oh, you
not gonna
don't
work.
have.
I need a USB-C.
Oh, you need a USB-C. There you go.
See if I can figure out the right command to share it properly. Or maybe. Aha. How do I do that? Okay, so last week, Gurhidar, whose name I probably just butchered, Giri, asked me to remind people about this spec that Qualcomm, a bunch of people from Qualcomm have submitted. So this is our actual first token binding extension, which of course Brian's reverse proxy would eat. But this does actually, this is an example of an extension that doesn't have, is going to have to be added in specifically because they have, each extension is likely going to have different processing rules that the reverse proxy is going to need to take care of. So the general idea, as near as I can make out, is that Qualcomm thinks it would be a good idea if we could have attestations at the token binding layer so that you know how the key is stored and other sort of network-based information. So they're imagining in one case that you would have protocol analyzers looking at your traffic and raise flags based on attestations from traffic coming from devices at the HTTP layer. Has anybody in the room actually looked at this specification? Tony, you looked at an old version of it. So they would like us to adopt this as a working group document, but it would be a good idea before we do that for some more people other than Tony and Brian to have a look at it. I think this probably needs to be fleshed out. The notion of having an attestation at the token binding layer isn't maybe useful. It may be useful for web authentication, which is one of the things that they're thinking of, knowing how the token binding key that underlies the token binding that WebAuth signs over could provide some additional context. Not that attestations for web authentication aren't controversial enough, but this would be yet another one.
Andrei Popov, Microsoft. So there is great interest from a number of teams actually at Microsoft in using attestation with token binding, because the security of token binding and the degree to which it improves the security of the token depends on the strength of the key storage solution that is being used. So there is great interest in this. I have not read the latest version of the draft yet, but I've read a previous one, which was more exploratory. So I would like to read this draft before I make judgment on whether we want to adopt this or not. But I think the actual area is very interesting to explore.
Right. So the general idea has some support, but we have to figure out whether or not this is the right way to approach it. I believe that there's also we'll talk in the OAuth meeting about device posture stuff that we're looking at for OAuth, and the Microsoft team at the W3C meeting last week was quite interested in some of the new attestation stuff that you guys have been working on. Might be useful for both of these things. So we won't call for adoption right now, but people can provide some feedback to the list. Maybe we can call for adoption as a working group document if there's general positive feedback. Okay. Other open mic issues? Anyone wanting to do show tunes?
Has the document been shared? I think it was in the end of last time.
We can send it to the list. It's in the list of working group documents.
Was it presented in clause? It's never been.
No, it's never actually been presented at a.
Nobody stood up to talk about it.
Right. So the authors haven't managed to come to an IETF meeting yet. Perhaps the next one, I think they were saying.
All right.
Anything else?
Anybody with open issues on their mind, pressing needs to do show tunes? No, but they will be minuted and recorded, including your show tunes.
I have a preference
Hi, Jeff
Not to
Hodges.
place the two.
There you go. I got here late. I'm sorry. So, what did you guys say anything about the HTTPS draft relative to last call?
Yes, we did.
And what did you say?
I said that we discussed it with the area director, and there was confusion in his mind about what constraints we were actually assuming. So we discussed that this was intended to work with Federation protocols as opposed to just random stuff being passed around the internet. So we agreed that we would add some explanation of, this is anticipated to
Okay.
be used in Federation protocols that have audiences and
Right. Okay.
check redirect URIs or have signed messages, etc., and needs to be used in combination with those things to have it be secure.
Okay. So he's not ready to push it into.
Oh, he
IETF
said that he
wide
would do
last-
that. He was planning on doing that today,
Okay.
based on our agreement to add some
language.
some
Okay.
non-normative
So I
language, yes.
replied to that at lunch right before this meeting. That's why I was late.
Okay, I haven't seen that yet.
And in my message, I'm suggesting, he really should have sent it to the list. His comment. I think that stuff should go to the list. So I think he was mostly sort of not sure whether his comments were legit or not.
But
I think
they
he wanted
are.
to bring it up with the authors, and they are legit within if you're not making certain assumptions, which most seem to be making. Yeah. Anyway, especially if we're going to make changes to spec in regards to these comments, they need to be on the list. So he or somebody needs to send his comments to the list, and John's reply and Andre's and mine need to go to the list, please, one way or the other. I think that's excellent feedback for the AD if he was here, right? And I will. Excellent, right? I think you're right. There's nothing in there that sort of anybody needs to hide about or be shy about. It's just sort of comments, and he could have easily sort of made them to this. I think it was just sort of hesitation whether he had understood the issues correctly. Yeah, that's fine. Hi, Jeff again. So also, if there's any notes on the discussion, because I missed the discussion because I didn't see the messages until during the first session this morning. So if there's any notes from the discussion, please forward them to the list. Right? Noted. Anyone else? So otherwise, you get a full hour back of your time. Hey, not bad. All right. See you in London. Oh, by the way, if anybody came in late and forgot to sign the blue shit, it's up front. The blue shine.